Metalworks table. We've got 3 programs we're going to be using. Inkscape is our CAD software where we'll do our drawing. SheetCam is where we import our drawing. We'll choose what gauge of material, what amperage consumable we're using, and how many copies of parts we need. And then Cyrious Command CNC is what operates the table, and that's where we'll import our G code into our into Command CNC to be able to cut it.
So you cannot use UWG files for it has to be G code?
No, so you can use SVG or DXF. Inkscape only exports as an SVG file. So whenever you bring in parts that you want, so say if you have somebody already has like a DXF or an SVG, you'll bring them into SheetCam, and SheetCam will convert those into a G code.
Oh, okay.
So we'll just start off in Inkscape and we'll do a simple 3x3 square with a 1-inch circle. Over here on the left-hand side is your toolbar. So I'm going to go ahead right now and just grab the square tool. And with this, you can draw anywhere on the program. And I'm not worried about my size just yet. And then I'm going to click on my circle tool, do the same thing. And then click back on my cursor. All right, you've got your width and your height up here, and you have an X and Y value. That X and Y value just gives you a spot to reference from on that square, but like I said, you can draw anywhere on this program. One thing to note with Inkscape is every time you open it up, it will always open up in metric, and you'll have to change it over to inch. Reason being, Inkscape's a European-based program, so it just always does metric. So I'm selected on my circle tool, so I'll go ahead and just size it up. So we'll do a 1 inch by 1 inch. Then on the square, it'll be 3 inch by 3 inch. All right. So now I can sit here all day and try to get that perfectly centered up, or I can highlight both parts. I've got this tab open right now to be able to align it. Depending on what you're working on in Inkscape, this tab might not be there. So to find it, you go to Object and Align and Distribute, and that'll pull up this tab. So real quick right here, we've got, if you hover over it, it'll say center on the vertical axis and horizontal, and that'll true that up in the center of the square. All right, so we've got our part we want to cut, so I'm ready to save. So I'll go up to File, Save As, and I already have a cut files folder created. If you ever need to find it, you can just go to Home, and there's cut files. We'll just save this one as drawing, and it's saving as an SVG. All right, now we can either minimize or close out, it does not matter. But we'll jump into SheetCam. So with SheetCam, this red square is showing a 4x4 sheet of material. We can physically change this square to size up to whatever drop piece you have. So if we want to size it up to that piece, we can. Our water table is larger than a 4x4, so that you've got at least 2 inches on each side of your plate, so you have a little bit of room. You don't have to worry about the torch running into the edge of the table. All right, so first things first, we want to bring in our new part. So we'll go File, New Part, go to Home, and Cut Files. So if you notice right now, there's no files in here. So if you look here down at the bottom, this is your file format, and we've got it selected on DXF. So like I said, we can either use DXF or SVG, and Inkscape only exports as an SVG file. So there's our SVG, there's our drawing, and we'll hit open. So with SVG, you'll have to change your scaling. So scaling for SVG is 1:1, and scaling for DXF is 1:25.4. Now, whenever you're running a DXF, this will automatically update for you, so you don't have to mess with it and don't have to worry about it. The only difference is you'll have a drop-down menu here, and it'll say, do you want it in metric or inches? And we'll change it over to inch. So right now, we're 25.4, we'll change it over to 1. If for whatever reason you missed that step, it's just gonna make that part 25.4 times larger than it needs to be. So you just delete it, restart again, reload it back in. We're always working at the lower left-hand corner, and our table 0 is at that lower left-hand corner. All right, there's our part. So we've got our part brought in, so now we need to do our jet cutting operation, and this is where we'll choose what size and what amperage we're cutting on. So down here under operations, that first tool kind of looks like a paintbrush in a way. You hover over it, it'll say create a new jet cutting operation. Now this is where we'll size everything up for our part we're working on. So most of the time you're going to be using an outside offset. One great thing about sheet cam is it'll be able to know what's dropping, what's not for the most part. So even though I've got an outside offset, it's going to be able to pick up and know that that center circle is going to be an inside, so it'll automatically update it for us. So we'll choose outside offset. Now layer is always going to be a default name unless we physically change it and give it a name. So right now it's color 1 million. Sometimes it's color black, color white. I've seen default, tool. There's all kinds of different names it'll give you, especially if you're getting files from different programs and different CAD programs. All right, but as long as you have something selected here, you'll be fine. If you leave this blank, it'll throw a code and let you know, hey, the layer is missing. All right, and the next is going to be our tool. So if you click on this, we've got all the tools preloaded in here. You've got an 85 amp, so you have the capability of using fine cut, 45 amp, 65 amp, and 85 amp. And all those tools are already built in. Aluminum, mild steel, and stainless steel are built in here as well. So right now, currently, I've got a fine cut tip in the torch, which will go more over what has to do with all the tips. So in here, one thing to note is fine cut and 45 amp are two different settings. So if you try to use 45 amp for fine cut, it won't work. It'll basically make the torch just rise up, and vice versa. So down at the bottom, we've got mild steel, and you said that's 1/8, so we can choose 10 gauge. So down here, T93, mild steel, fine cut, low speed, 10 gauge. Oh, I clicked onto a page. So the difference between fine cut and your regular 45 amp is your fine cut's going to be more detailed. It's going to have less heat, smaller kerf width. That way, if you're trying to do really tiny parts, it'll end up helping you with that. A lot of the times, if you're doing real thin material, so 16 gauge off to 26, helps with warping as well. So you've got your three main things you're going to be messing with: your contour method, your layer, and your tool. The next thing we have down here is our lead ends. I really don't worry about lead outs myself personally. Lead ends, we factory set this at 1/4 inch, but say if we're trying to cut some 1/2 inch on this table, you want your lead end to match the size of material you're working with, or larger. So if we have 1/2 inch, we want to have a 1/2 inch lead end or larger. That way it's got enough time to pierce through, and so it's got enough time to pierce completely through the material before it starts cutting your part. That way you don't have to sit over here and try to chip it out or try to bend it out. And once I hit OK, it'll give us a cut path. So it's going to start here, jump over to the center. Like I said, this is an inside offset and this is an outside offset. So sheet cam's already able to pick that up for us. But you got your S1 here, so it's going to cut out the first part, move over to S2, and continue. All right.
Can you change the sequence?
Yes, you can. So say if there's two different ways we can do it. So if I jump back into my jet cutting operation, you can just double click on it. I can choose an inside offset, and that's basically going to flip them. The other way is we can, I don't want to get too involved with that. Let me delete this real quick. But we can name the layers themselves. So up here in this toolbar, we've got Edit Contours tool. And over here, I can physically select on each layer, what sheet cam's going to call each line a layer.
So if you're cutting like 20 of these, you want to cut all the holes first.
Yes.
And then come back and cut your outside. You could select each layer.
Yep, you could say if we have multiple holes, all the holes here, I can physically hold down Control and be able to select each hole.
Gotcha.
And do one operation for that to where it does all my holes first,
Yeah.
and then
you
comes
come
back
back
and cuts
cut
my
all the
squares.
outsides. Yeah.
And one of the great things about that is, you know, with plasma in general, you're always going to have a curve, or what do you call that? You're going to end up having just a bevel
Yeah.
whenever you're doing holes.
Yeah.
And one thing to clean those up the best way you can is by doing a separate operation for the holes. So let me go ahead and make a copy real quick, just to show that. Up here, well, I'm sorry, let me continue this real quick. So I'm gonna select on this hole, right click, move to layer, and new layer. And this is where we can name this. So we'll just name that hole. And this side, right click, move to layer, new layer, and square. All right. So one thing to note, whenever you're doing copies of parts, your jet cutting operation has to be done first. If I do multiple copies without that, we'll have to go in and do every jet cutting operation separately. It'll just take too much time, and it ends up making Command CNC where it doesn't recognize things, and it'll end up trying to cut that part 3 or 4 times in the same spot. So always remember, if you're doing copies, your jet cutting operation has to be done first.
The jet cutting operation, you mean the one that you designed, right?
Yes,
Or-
the one right here where we set up the tool path. And so right now,
But you gotta reverse that.
Yeah, it's still in the wrong order.
so, well, I went ahead and deleted it already.
Okay.
So we're starting back over.
Gotcha.
So right now we're gonna do our first operation for the hole. So I'm gonna do an inside offset, because we're inside. Layer, now I can select the layer that we named. So we've got our hole. And now, to be able to clean that up, say if we're cutting 1/2 inch material, we wanna get it as clean as possibly. We're gonna try to cut our feed rate down by half. So sometimes it's 65%, sometimes you even have to go down to 75 whenever you're cutting 3/4 inch, just to try to clean it up. So a good method is just 50%. So feed rate right now was 100, so we'll just change it to 50 and hit OK. Now we'll do another operation, and we're just going to do the square
Outside.
now. So it'll be an outside offset, square, and your outside feed rate needs to be just the original feed rate. So say you lost it and you don't remember what it was. It was 100, but right here, this 3 dotted box is the complete tool set that was built, and it'll let you know exactly what the feed rate was. But as long as you don't hit update operations right here, this will all stay the same.
So is that inches per minute or 100%?
Inches per minute.
Since students theoretically can access this, is there a way to disable update operations?
There is not, but all the tool sets, say if somebody ends up messing with all the tool sets on here, we've got them pre-saved to the computer. So, I mean, it's just a simple, give us a call. I'll be able to walk you through how to reset them all, and I can give you updates and things like that.
It's gonna be a long time before any students touch this thing.
Well,
Yeah.
it should be, but they can't.
So like you were talking about earlier, if you wanted to change the operation, we've got our hole first, and then it's doing our square. Say if we wanted to flip that for whatever reason, we wanted to cut the square first and then the hole last, which you would never want, you can just drag this up and it'll end up changing it. So it's hard to tell right now. It's still showing S1 right now, but if you look right here, it's going to cut the square first and then move down and cut the hole. So that's kind of the different way. I'm not trying to confuse y'all a whole lot.
I mean, that's pretty much the line of operation, right? Top,
Yeah.
top
Correct.
down.
That's the way
or
you
sequence of
can,
operation.
yeah, that's the way you can adjust your operations if you wanted to change those. But other than that, SheetCam's going to be able to pick everything for you unless you physically do everything yourself. So
Now,
change these.
say you wanted these two to be mating parts, is there a way to create the lead-in line on the actual cut line and just have it go a further rotation?
Yeah. So can you explain that a little better for me?
So you want that circle to be a complete piece. Is there a way to prevent the lead-in?
Yes.
Well,
yeah,
you would
huge.
have to cut a circle and do outside operations if you want to keep the circle,
Yeah.
right?
Well,
We're cutting a hole,
Yeah.
a bolt hole. If you wanted to cut an actual circle, then you make a circle and you do outside operations. So it cuts on the outside of the circle,
Right.
right? That's the difference. So it won't actually pierce in the center of the hole because we're cutting a bolt hole essentially,
yeah.
right? If you wanted to cut a circle, then you make your circle whatever size you want. You do outside operations, and then it won't cut into your circle.
Correct. All right, so we've got this set up. All right, so the next step, we've got our operation done. All we need to do is 2 saves. The first save, we're going to save the job file, And the reason why I save the drop file just makes it a little quicker. Say if y'all won't have this situation, but if you had a customer that comes in and, hey, I need a test piece cut, you cut it for him, you spend 6 hours on the drawing, he comes back 3 weeks later, hey, I need 10,000 of these, but I need a thicker gauge material. You can just come back into the job file and adjust the gauge of the material versus having to find that file through the millions of USB drives you got laying around.
Yeah.
It just makes it a little quicker. But you do not have to save the job file, but if you want to do any editing later, it makes it easier. And then the next save we're going to do is run the post processor. And we're going to be saving all these into the cut files folder. And it keeps the same name that we had originally in Inkscape. Moving to SheetCam and then to Command CNC will always have the same name, so it doesn't get confusing and have millions of different files with different names. So once we save the post processor, it'll let us know post processing completed. I like to use, say if you're trying to do a design like a tree, you've got a lot of intricate branches and leaves and things in the drawing. If your cut paths are too close together or intersecting, this will pop up and let you know, hey, there's an issue with the drawing. Take a double check. It will still let you cut, but it just, hey, just take a visual real quick and make sure this is what you want to cut. Same thing if you have a missing line or an open line, this will let you know. So we've got our saves done. Now we're going to move to Command CNC. So every time we open up this program, it's always going to be an e-stop. When our controller's on, I've got it on currently, but if this controller's off, you will not be able to get out of e-stop. This is your motor control. So anytime this is turned off, you can move your gantry either way. What I'll recommend doing is whenever y'all are powering on, every time y'all power on or in the morning, to home the table. And what that's going to do is align the gantry up. We've already got, you've got homing switches on each side of the rail, and you've got a homing switch up on the x-axis. So, like I said, it's always it'll be an e-stop until the controller's on. And to operate the table, you'll just be using your arrow keys. So you've got your down, up, left, and right. And to control the Z up and down is your page up and page down. And for rapid travel, you just hold shift and speed it on up. So to home the table, you just want to bring it up to your homing switches. Get it close. And then we're going to hit home X and home Y. The tail will go ahead and home itself. Alright. So I'm going to go ahead and bring it apart so I can just go to open. And then to find it, it's going to be in plasma and cut files. There's our drawing. It'll go ahead and give you a live view, and it'll let you know what your workspace is with the added kerf width as well. Alright, so first things first, we'll get our torch where we want to start cutting from. And I like to bring my torch down to where it's at least a quarter of an inch or eighth of an inch away from touching the material, just so I can kind of see where I'm working. So once you get your torch where you want to start cutting from, like I said, we can cut anywhere on the table. Our torch is just going to be cutting from the lower left-hand side moving up. So we're ready to zero everything out. So we're going to 0X, 0Y, home Z. It'll come down, touch off the material. Once it touches off, it'll jump up to its initial pierce height. And then we'll zero from there. We are ready to run. So I'm going to hit run. This operator message will always pop up after you hit run. It's just letting you know to double check your preset volts and your preset amps and make sure they match. So we've got 89 and 89 in the G code, 45 amp, 45 amp. We'll hit OK, and once I hit resume, we'll start cutting. I'm gonna cut a second one real quick, and I'm gonna show y'all how to recover from a crash and how to recover your part after a crash. Not too bad. So same process again. We're in a 0x, 0y, home Z, and then 0Z. I'm gonna speed up my touch off just a hair bit.
So the location that you have it right now, is that the corner of the park, or is that where it's going to come in from?
So that's, once I have everything zeroed,
It's outside the corner of the park.
Bottom
Yep.
left corner.
so even though I've got my lead in, you kind of got to make sure you've got at least enough room for your lead in to fit on the material as well. So once I'm zeroed out, you can see right here with this blue cross, let you know exactly where your torch is.
Okay.
So another thing our table offers is collision detection. So I don't know what the torch mate had, if it was magnetic breakaway or what it was.
Yeah, it was.
It was magnetic. With magnetic, over time, those magnets make it to where you can move your torch around. It's never really centered up. With ours, you've got two collision detection switches here. And if you notice, these red lights are on. Whenever these red lights get turned off, it will throw the machine into e-stop. So I'm gonna go ahead and demonstrate a crash. And we're gonna cut the circle, and whenever probably halfway through the square, I'd like someone just to hit the torch and hold it off. Alright. So if you know, go ahead and hold the torch for the red lights are off. So when those red lights are off, you will not be able to get out of e-stop. So to bypass it, to clear your jam, you have an auto, manual, and MDI tab. The auto side is your G code. In the manual, you have your override limits. So we'll click on override limits, click on your e-stop, and then you're just gonna hold page up until you clear your jam and your red lights come back on. That'll be able to get that out. But say we're lost now, we look over here on the auto side, that purple highlighted line is where we stopped at in our code.
Nice.
So going up is our past code and going down is the future. So what we want to do is go into our past code, find our last M5, that's the last time it came down and touched off the material, and we're going to try to run from that line. With our system, you won't be able to run the torch completely from exactly where it stopped at. We'd have to do a dry run until we're about a 1/4 inch away from where it stopped, and then we're going to refire the torch to save it. So to do that, there's our purple highlighted line, and there's our last M5. But if you ever get lost in your code, you don't know where you're at, you can always scroll into your part. Okay, there's my line I started at, and that will get you close to your last M5. All right, so last M5 is highlighted. Down here underneath the torch off, you have the disable torch. We're gonna check that, and then we're gonna hit run from line. If we end up hitting run, it's just gonna start the whole program over to where it tries to cut out the circle. So anytime you're running code, running from a line, you wanna hit run from line. So hit run from line. That wasn't the right. Let me get back here again. It was. Okay. Like I said, 1/4 inch away from where it stopped, we'll refire the torch. What do we have going on there? I lost there. So that's another thing. Anytime you lose air pressure, you have something going on with the consumable, the plasma cutter will let you know what's going on. So currently we have a yellow light on, and it's got a code on it that says 0-20. So in this little booklet, we have a code list. So right here, 020 output gas pressure too low for selected process. You got 022, which is no gas input at all. 030, which is one of the more common ones you'll end up having, is consumables stuck. That there's a spring inside those consumables, and over time, once they heat up, that spring loses tension, and it just means it's almost time to replace them. If you keep getting that code, go ahead and replace your consumable. But just randomly out of nowhere, usually will come on. You just have to clear it. And that is a sticker, so if you want to stick it somewhere, you can.
Just hook it up to the line outside.
We got that one over there.
Oh yeah.
Behind the locker.
That thing always loses pressure.
Yeah, I don't know what's up with that. Maybe it's all raining. That line dryer.
I think you got enough in there.
I don't know how long it's gonna last.
Yeah, if you want to go ahead and turn it off. Alright, so we'll go through the same process again to be able to save that part. Last in 5, run from line, save the torch. We'll go ahead and run a dry run. I'm going to refire it now. I did it too soon. I didn't know how much it cut without the hair. Try that again.
So pretty much when you're ready to use quick and disable.
The disable torch. So when it's
But
checked,
you're enabling it, right?
right.
Yeah.
So right now when it's checked, it means it's completely disabled. And when I'm a 1/4 inch away from where it stopped, when I click on that again, that refires the torch. You want me to run another test real quick, just so y'all can see it, or?
I don't know. Yeah, I guess so. Okay. One more.
So another thing too is after you're cutting, if you don't have access to your keyboards, or not your keyboard, but your arrow keys aren't moving the gantry, sometimes you'll have to hit escape and they'll give you access again. Alright. 0X, 0Y, home Z, 0Z, ready to run, and resume. Alright, so we get our red lights back on, manual tab, override limit, e-stop, and then hold the page up until your red lights come back on. Alright, to save it and restart, we're going to scroll up to our last in 5, disable our torch, and run from line. It's going to run that dry run, and then when we're a 1/4 inch away, we'll click on disable torch again and save this part. Alright. So that takes care of the training side on the command CNC. I'm going to jump back into sheet cam and do some more things, show y'all some more things. Styles, new job. File, part. I'm just getting this set back up real quick. Alright. So like we were talking about earlier, if we're going to do any nesting, copies of parts, we have to make sure our jet cutting operation is done first. Then up here in this toolbar, that cross says nesting, we'll click on it. We can right click anywhere on the outside of that or near this part. And you've got a couple options. You've got duplicate, which is just a single copy. You've got multiple, which is just copy and paste.
Will it allow you to stack the lines? Like if you wanted to stack them closer and just make a single cut?
Minimize drop.
Yeah.
It does. Me personally, I haven't had any experience setting that up myself.
Gotcha.
But I believe, so to cancel this, you'll just right click, hit cancel. But I believe it's set up in the max chain length.
Okay.
And I just, myself, I don't have any experience setting that up yet.
All right.
but there is a way to set that up. If you ever need a backspace, you can hit Control Z, and that'll delete whatever items. If you end up moving something out of the way, you can hit Control Z and undo. And the other option you have is multiple duplicate. Oh, that's the one we already did. Sorry. Is array parts. So array parts, this will array whatever size the material you have on the table. So right now it's set up for the 4x4. So if I set my part spacing, if you want to do, I believe you can do the grid spacing right here, but I don't think you would have your lead in, but I won't get too far into that yet. We know we've got a 1/4 inch lead in, so I'm just going to do my part spacing by 0.3 and hit fit to material. So we've got 14 columns and 14 rows, and once I hit OK, it'll fully nest a sheet for you.
Okay.
And then if you ever need a backspace, like I said, Control Z. When you have a lot of items like this, sometimes Control Z will end up, it has to delete all the G code, so it takes a second.
Takes a minute.
Sometimes it freezes when you have a lot of things.
Didn't you say the lead in is equal to the thickness of material?
Yeah.
Mm-hmm.
Okay.
So like right now with 10 gauge, technically we don't really need a quarter.
Yeah.
But
That's just what I was saying.
and really where it starts at as is 1/4 inch material, that's when I start adding larger lead ins. So like for 1/2 inch, I always do 0.55 lead in for mine.
Just a little bit extra.
Yep. Just to be sure.
So we could 1/8 inch, you could put an 1/8 or 16th, you could put a 16th lead in.
Absolutely.
Okay. Yeah, you could.
Absolutely.
Okay.
So another thing that you can do here in Inkscape is this up here in the toolbar again. You've got this square with 4 holes. It's our shape library. So you click on that, hit new shape, and you've already got some preloaded gussets in here, shapes, triangle gusset, web stiffeners,
Yeah.
specialty shapes.
Sweet.
You've got your basic shape. So say if you didn't, for whatever reason, you didn't want to go into Inkscape, and then you've got brackets and mounts. This is where you got pipe saddles, the rectangle with 4 holes, and pipe flanges. I like using the pipe flange for an example.
Yeah, let's cut one of those.
Okay. We'll get this set up real quick. So once you've got it selected, it's always going to put this in a randomized spot on here. Never really worry about the X and Y position. The only thing you need to worry about is just having it close to the
Yeah.
lower left-hand corner. Say if I have it over here and I zero everything out, get it set up, that torch is going to move all the way over here on the material. So
Right.
you just want it down here close to your edge. So you've got all your parameters over here. So say if you want to do 6 inch. Your part spacing, say if you want it 4 inches. Number of holes.
Let's do a
6
4-inch
inch.
ID.
So
With 6 holes.
So 4-inch ID with 6 holes. Probably 3. And I believe the PCD here is the part space or the hole spacing. I believe
6 is fine.
So 6 holes and then hole diameter size.
1/2 inch.
Okay. And then you can also do a square hole, a block off plate if you need to, and then you can size up the center hole size as well. So right now it's just 2 inch. And one thing, we've got it sized up.
Oh, you did a 4-inch OD outside
yeah.
that? Oh, do a 4-inch ID. So that would put our,
So the center hole,
yeah, center hole, 4-inch.
You want a 6-inch plan?
it won't let me do.
Yeah,
So,
you're
oh,
gonna
we're already
you're gonna
gonna
increase,
that.
yeah.
Do that
So,
one
6 inch?
6, yeah.
Okay. That's where we're messed up. Okay.
Probably 5, yeah.
Yeah. So 6 inch, outer diameter, 6 holes, 1/2 inch, and center hole size 4 inch.
That'll work.
Okay. So I'm just gonna
So
place
even
this
if you put it
close.
there and we have already cut these squares out, I mean, oh, I guess you could start the torch.
Yep.
from
We
here.
can zero
It
anywhere
doesn't
we'd
matter.
like to.
Gotcha.
Yes, sir.
Awesome.
All right. So then after you've got it sized up the way you want it, we're gonna hit the add current part. Reason being, even though this is a part of sheet cam, this technically transfers it into sheet cam. So we'll hit add to current part. Then I'm gonna click back on my cursor. And I'm gonna go ahead and just delete this square real quick. Oh, Control Z. So I may have just added that square in here. Yep, it did. Let me. Sorry. Let's go do this again real quick. Brackets and mounts. Where'd it go?
It's right there. There's
Where'd you go?
Specialty parts.
Sorry, that coming weird. I'm pretty sure it was in mounts and brackets. Let me close that real quick. They've done something weird. Okay, now I'm kind of confused. Because now it's gone. There it is. Okay.
Very bottom.
Alright, add current part. Now we can do a jet cutting operation. And this one is just going to be named shaped. Every time you make it from the shape library, it'll always pull up a shape. We'll hit shape, hit OK. So we did an outside offset. So it knows all these holes right here are inside offset. It knows to do an inside offset on the center hole and then an outside offset here. So we've got the jet cutting operation done. We'll do file, save job as. We'll name this one flange.
Hold on. Before you save it, can you show me where you saved it one more time?
Yes. So file, save job as, and then it's going to be in the cut files folder.
Yeah,
If you ever need to find it, you'll just hit home and then cut files. And then the second save, run post processor, and see how it changes to, instead of a job file, now it's an NGC file. And we'll save that to the cut files folder as well. So now we'll jump back into Command CNC, we'll hit open. There's our flange, there's our part. Now we'll just, I'll go ahead and cut up here. Zero X, 0Y, home Z, 0Z, ready to run. Hit OK and resume.
Very nice. Very cool.
A lot easier than the Lincoln.
Yeah.
Did they give y'all any training with that thing? I don't know.
I saw somebody.